Okay, page 106, the grade A questions. This is question 6 and 7 on the board there, on the screen. Now, the area of a shape, doesn't matter what shape it is, but we're told it's 7 centimetres squared. Please note it's an area. Each side of the shape, that is the linear lengths, each side of the shape is enlarged by a scale factor of times 5. Here's the question. What is the area of the enlarged shape? Now look very carefully. Question 6. We have a linear ratio. We're told the larger one is 5 times as big as the smaller one in terms of the lengths. There I go again with ration. It's ratio. So it's going to be 1 to 5. Okay, so whatever the length is on the shape, the corresponding length on the bigger shape is 5 times as big. Now the linear ratio is therefore 1 to 5. Now we're told to work out an area of the enlarged shape. Now you should recall that the area ratio is going to be the linear ratio squared. In other words, 1 squared compared with 5 squared. In other words, 1 to 25. So in terms of area, the bigger shape has an area 25 times as large as a smaller shape. So what have I got here? I've got 7 centimetres squared, and that's on the original. If I now go multiply that by 25, I should get the area of the bigger shape, and I'm sure I will. So 25 times 7, I've got myself an area of 175 centimetres squares. Please note, this is grade A. We don't take the ratio of 1 to 5 and multiply the area by 5. We're not going to say 7 times 5 is 35. So I proved to you from my original videos that if you're going to work with a linear ratio and you need to get an area ratio out of that, you need to square both parts. So if I've got a line, say 1 centimetre long, and the bigger line is 5 centimetres long, this is just me doing a sketch. By the time I go to area, look at this. I go 1 times 1 is 1 centimetre square, and 5 times 5, 25 centimetre squares. There we go, there's a ratio of 1 to 25 by squaring each of the linear lengths at the side. So 1 to 25, so this one's got 25 times the area of the little baby one. So 7 times 25, 75 centimetre squares. Alright, now let me do question 7. That was a bit quick. I didn't have to do this little bit, but I felt I had to. Yeah, I just did it anyway. The volume of a shape, right, volume is 4. Each side of the shape, that's the line length, the linear length around the perimeter, each side of the shape is enlarged by a scale factor of 5. What is the volume of the enlarged shape? Now here I go again. I've been given a linear ratio, and it's 1 to 5 again. Alright, these are starter questions, but they're grade A nevertheless. Now to go for the volume ratio, you may recall that you take the linear ratio and you cube it. Alright, remember going from linear to 3D. 1 cubed is 1, 5 cubed is 125. Alright, so the volume of the shape, the original baby shape, is 4 centimetres cubed. And what is the volume of the enlarged shape? Well, I'm not going to multiply 4 centimetres cubed by 5, that's just the ratio of their lengths. Now the ratio of the volume is 1 to 125, I've just proved it. Therefore I'm going to take my 4 centimetres cubed of volume for the small shape and multiply it not by 5 times but by 125 times. And that will give me, I can see that in my head, 500 centimetres cubed. Now that is absolutely shocking. Let me just do it just to be sure. So I'm actually in shock here. Look at me, I'm shaking. Yeah, look. Shocking, look. The linear ratio is 1 to 5. Comparing just their perimeters, say, if you knew the perimeter, the enlargement would be 5 times as big as the smaller one. But look at the volume. 4 centimetres cubed of volume becomes 500 centimetres cubed of volume in the 5 times enlargement, which is truly shocking. But there it is. That's the way the maths works, and it's in fact true to life anyway. Let's try and do a few more questions, and this might make the video a little bit long, but let's see how I might edit it. See how we go. Right, number 9. A cuboid is enlarged. Alright, the original length was 3 centimetres and the enlarged length is 18 centimetres. Let me just do this. A little cuboid, a titchy one, that's 3 centimetres, and the big one, and make it look a little bit bigger, I don't want to sort of fill the place up with pictures exactly. So here we go. I've got a length of 3 compared with a length of 18. Now the linear ratio is clearly 3 to 18, which I can simplify as 1 to 6. Is that alright? So if you like, in terms of lengths, from there to there we go times 6 in order to get the enlargement compared with the smaller one. So it's a linear ratio of 1 to 6. Now the original volume, the little one, this one has a volume of 24 centimeters cubes. Alright, so this one 24 centimeter cubes. Now this one here is going to have a volume 6 times as big, but wait a minute, you should know that the volume ratio is the linear ratio that's been cubed. So 1 cubed to 6 cubed, not 1 to 6. Alright, 1 cubed is 1, and 6 times 6 times 6, I can't remember. Yes I can, 216. Now this is truly shocking. See, even though I'm only 6 times as long in terms of the corresponding lengths, by the time I get to the volume and go 3 dimensions, I'm 216 times as big in terms of volume. Therefore I'm going to take my 24 and multiply that by 216 times, and I'm going to get my volume right now. So 24 times 216 equals, here it goes, 5,184 centimeters cubed. There you go, beautiful. The original volume is 24, multiply it by 216, what's the volume of the enlarged cuboid? Answer, it's an incredible 5,184. Alright, now let's try and do, that's question 8, let's try and do 9 on this video. Right, 2 similar flower vases have heights of 18 and 28.8. Well, I don't have to draw them very beautifully, do I? So here's a little vase, it's got a height of 18 centimeters. Remember, we're talking linear. Let's draw this slightly bigger so you don't start saying it doesn't look right. So that's 28.8 centimeters, and that's the height from there to there. Clearly it's an enlargement. It takes 0.5 litres to fill the little one. So this is going to be the volume. Volume equals 0.5 litres. How much water does it take to fill the larger one? So that's me putting water into this one. I'm going to say V equals question mark. Again, you don't have to draw this rubbish in an exam, just jump straight into the maths like this. But this is me like teaching it. Here we go. Right, linear ratio. Here we go. Start with the linear, always. Always. If it's given to you, that is. Linear ratio is going to be 18 to 28.8. Can be simplified. It really can. I could halve it just to make life easier. I'm going to leave it like that because my calculator can handle it. Now, we're playing with volumes. Therefore, the volume ratio is going to be 18 to 28.8, and they're each cubed. Now, actually, thinking about it, it could get rather big. So let me scratch that. If I divide, let me just simplify it further. I mean, it would work by me filling up the screen full of big numbers. Let me simplify it. If I divide each side by 18, that becomes 1. And I've got 28.8 divided by 18, that becomes 1.6. Now that's far more manageable. So the enlargement is 1 to 1.6 in terms of the linear ratio. Alright, so it's a times 1.6 enlargement, so to speak. Now it's quite easy to cube these. So I've got 1 cubed compared with 1.6 cubed. Well, 1 cubed is 1, and 1.6 cubed, let's just cube that. Here I go. 4.096. It's about 4 times as big in terms of volume. So let's look at it carefully. How do I get from there to there? I'm going to take my 0.5 litres original and multiply that by 4.096, and that'll be the volume of my bigger vase. So 0.5 times 4.096 gives me a volume of 2.05 litres, say. Now that's about 4 times as big, isn't it? But it's not 4 times as tall, is it? Look, if that is not, for example, I don't know, 60 odd, it's only a little bit taller, 10 centimetres taller, and yet it contains almost 4 times the volume, in fact more than 4 times the volume. Why? Well, the ratio is greater than 1 to 4. It's 1 to 4.096. So I'm quite happy with that. Let's just cube up again, make sure I did that correctly. Yeah, 1.6 cubed is 4.096. That's fine. Now that's proper grade A questions, and you need to study this, because when I start doing 10, 11 and 12, these are really tricky, and they're going to be challenging. So you better look these over, 6, 7, 8 and 9, and get back to me for the really dodgy ones.